Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, in this lecture, I am going to discuss the basic concept of Stoke's theorem, how we can use the Stoke's theorem, and how many type of question solve with the help of Stoke's theorem. So, we want to discuss in detail about the Stoke's theorem in this lecture. Basic concept of Stoke's theorem: relation between line and surface integral. Any line integral is given in our question, and how we can change a line integral in a surface integral. Then we can find the value of surface integral. And Stoke's theorem also verify in the question. Means left hand side is line integral and right hand side is surface integral. Both should be same. So we find out the value of first line integral, and after we find out the value of surface integral, and both sides have same value. It means Stoke's theorem is verified in the question. So questions are here two types. Number one, verify the Stoke's theorem. Any vector point function is given in our question, and there is under the surface, and some boundary values are given of the surface which is bounded by the surface. Then we can find line integral and surface integral, and both integral have the same value. Then Stoke's theorem is verified. This is the first question. Another problem is find the value of line integral. Then line integral convert into surface integral, and we find the value of surface integral, that is equal to value of line integral. So these two problems basically I want to discuss in this lecture in detail. So first of all, I want to define of Stoke's theorem. Define of Stoke's theorem. This is wrong here. Definition of Stoke's theorem. Stoke's theorem. Stoke's theorem. What is Stoke's theorem? So if S is an open surface, S is any given open surface bounded by closed curve C, which is bounded by a closed curve C, and F is any vector point function. This is the value of the point given at any point on the surface. At any point. This is the function value of F vector point function. This is the value of the point on the surface. At any point on the surface is any vector point function having continuous first order partial derivatives. Having continuous first order partial derivative. Then this is the formula of Stoke's theorem here. This is line integral, single integral C under any curve C. F is any vector point function dr. R is the position vector, and dr is the differentiation of position vector of a point. This equal to must be double integration under surface S curl F dot n ds. This is the surface integral, right hand side. This is the line integral. Basically, this is the relation between line integral and surface integral. Relation between, here I am writing here, basic concept of Stoke's theorem, relation between line and surface integrals. where n unit vector is a unit normal vector. N cap is a unit normal vector at any point on the surface and perpendicular to the surface. And is unit normal. Suppose this is surface. This is perpendicular to this is the direction of the unit normal vector n. Perpendicular to the surface. This is surface. So this is the direction of normal. Unit normal vector n perpendicular to this surface. Above formula is given in vector form of Stoke's theorem. Stoke's theorem formula is given in vector form. N is unit normal vector perpendicular to the given surface. Now change the above formula in vector to scalar form. How we can change the Stoke theorem, formula of Stoke theorem in scalar form, vector to scalar form. But now the number of values given in the vector form or in Stoke theorem. So value is given, first is vector point function. Here given vector point function f. F is given here. F is given vector point function. This is the value of the function at any point on the surface. So vector point function, first of all, this is line integral. Left hand side, this is LHS. LHS, left hand side. Left hand side is, formula is line integral. Line integral means integral C. C is any curve. C is any curve and F is vector. F vector is, F is vector point function and dr vector. Dr vector means this is the vector form differentiation of position vector at given point on the surface. So R vector is any position vector of a point, then dr is the differentiation of position vector of a point, and F vector is the value of the function at the position of a vector at any point on the surface. So convert equation 1 from vector form to scalar form. That is very easy to change in vector form to scalar form. So F vector is given here, F1 I cap plus F2 j cap plus F3 k cap. F1 and F2, F3 are component of the vector point function in the direction of x, y, z respectively. F1 along x-axis, F2 along y-axis and F3 along z-axis. So this is equation 2. And unit normal vector n is unit normal vector. So cos alpha I cap, cos beta j cap and cos gamma k cap. Cos alpha I unit vector plus cos beta j unit vector plus cos gamma k unit vector. This is equation 3. This is value of n cap. This is the value of vector point function f. And next, vector position of vector r. Any point P is given in our question. Suppose this is x-axis and this is y-axis, this is z-axis. This is P point. Position is x, y, z. And this is OP. O is this. So here OP is this. This is point A point. And this, okay. This is the diagram. This value is x. And along this is I cap. And this value is y. Along this is j cap. This is also j cap. And this is value of z. And this is along k cap. So now vector is OP vector. OP vector is R vector. R vector is OAI and plus ABJ and plus B. Here is B. AB, this is B. And B, this is C. BC, K. So this is XI and plus yj and plus zk. This is vector r. Vector r is xi and plus yj and plus zk. Now derivative of vector r, that is dr vector. Dr vector dxi and plus dyj and plus dzk vector. So this is dr vector. So r vector is given y equation 4 xi cap plus yj cap plus zk cap. X, y, z are the component of the displacement covered by the point to go from O to P. O to P, some distance covered on x-axis, that is x, some distance covered on y-axis, that is y, and some distance covered on z-axis, that is z. And I, j, k are unit vectors along the x-axis, y-axis, z-axis. So total sum of the vectors covered by the particle point xi vector plus yj vector plus zk vector. So that is our vector. We have discussed of this vector in last lecture. So now this is vector r xi plus yj plus zk y equation 4. This is dr. Dr is derivative of r vector, dr vector. Dxi cap plus dyj cap plus dzk cap, this is equation 5. Now finding curl f. Curl f. Curl f means this is del cross f. Del cross f. F vector. Curl f means del cross f. Del cross f always be calculated with the help of determinant. This is cross product. Cross product means vector product. Vector product. Value of the vector product between two vectors finding with the help of determinant. So I am taking here determinant 3 cross 3 determinant. So here first row is ijk. Ijk are unit vectors taking in first row of the determinant. In second row del cross f. Del cross vector f. So del, there are 3 component in del. So dou over dou x with respect to x in I and dou over dou y, dou over dou z. This is the coefficient of I, this is the coefficient of j, this is the coefficient of k. Similarly, F1 is the coefficient of I, F2 is the coefficient of j, and F3 is the coefficient of k in our vector point function. So coefficient of I taking in I column, coefficient of j taking in j column, coefficient of k taking k column, respectively the given vectors. Here first vector is del vector, second vector is f vector. So first of all taking the coefficient of ijk in del in second row and coefficient of ijk in vector point function f taking in third row. After solving this determinate, so first taking I here. First row and first column cancel out and cross multiply. Remaining terms we taking cross multiply. So dou over dou y with dou over dou y of f3 minus dou over dou z of f2. Second is minus j. Second term is minus j and second row, first row and second column cancel and taking cross multiply. So dou over dou x of f3 minus dou over dou f of z, dou over dou z of f1 plus k last k and third column of first row again cancel and taking cross multiply. Dou over dou x of f2 minus dou over dou y of f1. So this side is in vector form. Curl f. Curl f is vector quantity. So now we find curl f dot n. N is unit normal vector. Curl f dot taking dot product between curl f and unit normal vector n. So here putting the value of n vector. This is n vector. So cos alpha I, cos beta j, cos gamma k. So curl f dot n, this is the curl f, and taking dot product between I to I, j to j, k to k. Then we get this formula, this equation 7. Now we find f vector dot dr vector. F vector and dot dr vector. F vector is f1i and plus f2j plus f3k. And here dxi and plus dyj and plus dzk. Okay. Taking dot product here. I to I, j to j, k to k. Then we get this equation 8. Equation 8 is f1 dx plus f2 dy plus f3 dz. This f1 multiply dx, I dot I is 1. This f2 multiply dy, j dot j is 1. This f3 multiply dz, k dot k is 1. Then we find this result. So now integral under curve C f dot dr equal to double integration under surface S curl f dot n ds. This is the Stoke theorem. Formula of Stoke theorem is this. Now putting value here on both sides. F dot dr is f1 dx plus f2 dy plus f3 dz. Like this, close in bracket. And here is double integration with surface S curl f dot n ds. So value of this result is integral C curl. This is same formula of right hand side. Putting value of this here. Double integration under surface S dou f3 upon dou y minus dou f2 upon dou z cos alpha minus sin dou f3 upon dou x minus dou f1 upon dou z cos beta. In second term there is no y, no f2, no y. In first term is no x, no f1. In last term is no f3 and no z and cos gamma. This is equation 9. So this formula represented in scalar form. The above formula is represent in scalar form. Scalar form of Stoke theorem. Stoke's theorem. This formula is scalar form, not in vector form. In vector form, we convert in scalar form. All vectors taking dot product and cross product. So basically, scalar formula we use in our question, not vector formula. Vector convert in scalar form. Then we find the value of the integrals. So now in this lecture, we want to solve some problem based on Stoke theorem. So problem 1 based on Stoke's theorem. This is very interesting problem and very important problem. Also very easy. With the help of Stoke theorem, we can solve this problem easily. So I have already told you just a minute. In our problem, there are two types of problem. First problem is verify Stoke theorem. How we can verify the Stoke theorem? To verify the Stoke theorem, in the formula of Stoke theorem, there are two sides, left hand side and right hand side. Left hand side is line integral, right hand side is surface integral. So we will find the value of the both integral left and right hand side. If both value have same, it means verify Stoke theorem is verified. If both value left hand side and right hand side are not equal, it means Stoke theorem not verified. Okay. So verify in our problem, verify Stoke theorem. Here we will verify Stoke theorem in this question. Vector f point function is given here. Here is only I and j. Two-dimension vector point function. K is not there. So here x square plus y square I cap minus 2xy j cap plus 0 k cap. No K. So 0K cap. Taking round the rectangle bounded by the lines. Taking round the rectangle. Our curve in the form of rectangle form. That is represented by curve. Rectangle is always be curve. In the curve form. So that is bounded by the lines. First line x equal to plus minus a. Plus minus means x equal to a and x equal to minus a. Y equal to 0 and y equal to b. These are boundaries. We are taking our diagram with the help of these boundaries. Okay. So solution start. Let C denote the boundary of the rectangles. C means curve. C is closed curve. That is represented by rectangle. And boundary of the rectangles are given in our question. Then we can draw our diagram. Rectangle is ABCD. ABCD is rectangle. Then integral C f dot dr. F dot dr is. Here is dr. Integral C and f dot dr vector. F dot dr. So integral C, here this is f. X square plus y square I cap minus 2xy j cap. In f vector point function there is no k. Third vector is not there. Means the component of the vector along z axis is 0. So that is 0k. 0k means 0. And this is dr vector. Dr vector means dxi plus dyj plus dzk. Now taking dot product here. Dot product means I to I multiply. Dot product between I to I and j to j and k to k. But in first vector k is not there. So the coefficient of k is 0. So 0 into dz, that is 0. So finally we get here I. This is integration. Line integral is given. This is left hand side. This is left hand side of the Stoke theorem. So left hand side is x square plus y square dx minus 2xy dy. This is equation 10. Here we have taken the left hand side formula of the Stoke theorem. One side we have taken here. Left side is integral C f vector dot dr vector. F vector is given here. What dr vector? That is dx vector I plus dy vector j plus dz vector k. So taking dot product here. Here f vector point function is known. But dr is already known. Dr vector. So now here making here diagram. This is rectangle ABCD. ABCD. D is here. ABCD. So this is origin. This is O. This is x-axis. X-axis is this. This is y-axis. Okay. This is y-axis. Now, in our boundary value, we have to give in x equal to plus minus a. Means x equal to plus a and x equal to minus a. So this is 0. This is plus a. This is plus a from here. This is minus a. Minus a this. And y equal to 0. Y equal to 0 this. And y equal to 0. And y equal to b. So y equal to 0 this result. And y equal to b is this. So now our point start from O. O to A comma 0. This point. Then A to B, this A and this V. This is V line. So A comma B. B to E. So this result is A2 minus A. Goes to A2 minus A. and E to D. E to D means E to D. B to here. What is point? B to 0. Here y is 0 minus A comma 0. So B to 0 here. So be calculating the value of the integral I according to this diagram. This is line integral. Our point goes to line integral. First start from A to B. First line is this. Be calculating the value of the first integral along AB. Next B to E. Next E to D. Or last D to A. So we will calculate here 4 integral. 4 integral means first integral along A to B line, next integral B to E line, and third integral E to D line, and last integral D to A line. After adding all integral 4, we get the value of the integral, line integral. This is the closed rectangle. So here the curve C consists of 4 lines AB, BE, ED and DA. AB is first, AB, BE, ED and DA. So now I1 is the value of the integral from equation 10. 10 is this last equation, this is 10. This equation 10. This is I this is general formula. When we are calculating the value of this integral in 10 along AB line, that is integral 1. Along BE line, that is integral 2. Along ED line, that is integral 3. And along DA line, that is integral 4. So one by one we calculating the value of the integral according to the lines. After adding all integrals, then we get the value of the integral in rectangle. So here now I1 is the value of the integral from equation 10 along the line AB line. So what is happening in AB line? AB line is x equal to A. This is parallel to y-axis. AB line parallel to y-axis. So there is no value of y. Any line parallel to y-axis means there is no value of y. There is value of A. So x equal to A. In this result, x equal to A. And dx, when x equal to A, then dx is 0. X equal to A means dx equal to 0. A is constant. So differentiating with respect to x, that is 0. So value of dx is 0 and x equal to A, putting in this integral. When we are calculating the value of the integral along A to B, AB. So 0, but y is going. Y varies from 0 to B. Y start from A and goes to B. So value at A y 0. Value at B of y B. So limits of y is 0 to B. Limits of y from 0 to y equal to B. So these value putting here, be calculating value of I1. This is integral C. C is now AB. C is confirmed. What is C? What is curve C? Curve C is a line. Line is AB. So here we taking in place of C is AB because we are finding value of the integral along the line AB. So x square plus y square dx minus 2xy dy. This is same equation 10. Taking equation 10. So this convert in 11 because I am finding here integral along AB. We are finding integral along AB. So this equation 11 putting x equal to A and dx equal to 0 along the line AB. And y varies from 0 to B. So integration here, single integration is this. Because this is line integral curve integral. that is single integral. So 0 to b, dx is 0. So this term is 0. First term is 0. dx. dx is 0 here. So this integral, this term may vanish. Minus 2x, x is a here. So putting x equal to a, first term is 0. X equal to a, 2a by dy. 2a minus 2a is common out of integral and integration by dy. Y dy, integration by dy means y square by 2. Integration here y dy. So value of this is y square by 2. And limit is 0 to b. Upper limit b, lower limit 0. Putting here y equal to b here. So minus 2 is cancelled here. Minus a, here putting b square. So this is the value of I1. First I1. I1 is first integral along the a to b. Now I2. Value of the second integral is the value of the integral from equation 10. I am taking same equation 10 along line BE, B to E, where y equal to b and dx equal to 0 in along to b. This y equal to b, then dy is 0 and this x varies from a to minus a. X varies from a to minus a. So here dy 0, not dx, dy 0. Y equal to b means dy equal to 0 and x varies from a to a. Any limit of x is a to minus a. So value of I2 same from equation 10. I am taking from equation 10. From equation 10. This equation 10. Here taking BE. BE. B to E. This integral along the line BE. BE line के according integral. Putting y equal to b, then dy 0 in 12. And x varies from a to minus a. So here I2 equal to minus a to minus a. Putting y equal to b, x square plus b square and dx. dy is 0. So this second term is 0. dy is 0. Putting in here in equation 12. So this term is vanish. X square plus b square dx. Now integrating x square integrating x cube by 3 plus b square is constant and here is 1. So integration of 1 is x. Apply limit a to minus a. First of all putting minus a then plus a. So here putting x equal to minus a ka cube by 3 plus b square into minus a. And minus sign. After apply lower limit, we take here minus sign. So here putting value x equal to a ka cube by 3 plus b square a. So these are positive sign inside the bracket. Now multiply by minus sign, then these terms are negative. So here a cube by 3 minus b square a minus a cube by 3 plus b square a. Multiply by minus sign, minus a cube by 3 minus b square a minus a cube by 3 minus b square a. We see that here this adding this 2a cube by 3 and minus 2b square a. So this equation 13. This is I2 along line B to E. Along the line of the rectangle B to E. This is the I2. Now I3 is the value of the integral from equation 10. Every term we are using equation 10. Equation 10 is Stoke theorem. Left hand side of the Stoke theorem in scalar form. Along the line ED where x equal to minus a, then dx equal to 0. This is along the line ED. Where is ED? ED. X equal to here minus a. This is line parallel to y axis but in negative direction. So the equation of this line is x equal to minus a. X equal to minus a, differentiating with respect to x, then dx is 0. So here dx 0 and y varies from b to 0. Y limit of y is here, b c here, value of y is b and value of b is 0 here. b to 0 limit of y. So limit of y b to 0, now I3 calculating here, b to 0. Y varies means limit of y. So limit of y along BE along ED is y equal to b to y equal to 0. So I3 is the integral, value of the integral along the BE. So here is BE. So limit of v here, putting value in equation this 10. Value of y is dy is 0. Y is x equal to minus a. So dx equal to 0 here. Here x equal to minus a, dx 0. Putting in equation 10, dx 0. So minus 2xy. X is minus a. Minus 2 minus a into y. So 2ay dy. 2a. Integration of y dy y square y. 2 is cancelled. So now a, putting limit b to 0. B is minimum, 0 is upper limit, b is lower limit. So 0 upper limit, apply here 0 and lower limit is b square. So answer is minus ab square. Now I3 is value of the integral in equation 10 along dA. I3, this is I4. This is last value of the integral along d to a. So our rectangle is complete here. Along the line dA where y is 0. That dA along the x-axis and x-axis y always be 0. So y 0 means dy is 0. Both value putting in equation 10, y 0 and dy 0. And x varies from minus a to plus a. In our here diagram, here is d or here is a, d to a. So here is x is minus a, here is x is plus a. So limit of x is minus a to x equal to plus a. This is minimum limit, this is upper limit. So now our integral is I4 equal to dA integration y is 0. So 2 here in 10 equation, this y is 0. So this term is vanished. Y is 0, putting here y 0 and here y and dy 0. So this term is vanished and this term only x square dx remaining. Here is remaining term x square dx. Now taking limit in place of dA, taking limit minus a to a x square dx. Integration of this x cube by 3. Limit minus a to a. So first of all putting a cube by 3 minus sign minus a ka whole cube by 3. Minus a ka whole cube minus plus a cube by 3. So this is 2a cube by 3. Now adding all integrals, adding I1 integral, I2 integral, I3 and I4. Then we get here, this is I is total integral C. This is f dot dr. This is integral C. This is vector f or dot dr vector. F dot dr this. So this equal to I1, I2 plus I3 and I4. Value of I1 is minus AB square. Value of I2 is minus 2A cube by 3 minus 2B square A. And value of I3 is minus AB square. And value of I4 is 2A cube by 3, this last. After adding this term is cancelled to this. And this is 4 minus 4AB square. This is left side. We have taken this only left side. This is value of LHS. Now, P will also calculate the value of RHS of the Stoke theorem. So in RHS, here, now in RHS, we find first of all curl F. In RHS, his formula is double integration as curl F vector dot n cap or ds. This is formula. This is RHS of the Stoke theorem. So first we find the curl F vector. Curl F is, this is, we have already opened here. So apply here vector point function here. Here is 0, here minus 2xy. In same determinate like this. Here I and here j, okay. Here dou over dou x and dou over dou y, dou over dou z. Here x square plus y square and here 2xy, here is 0. Minus 2xy this. So now after calculating, we get same this. I taking first, this cancel, dou over dou y of 0. Minus dou over dou z of minus 2xy. And minus j second term, minus j. Second column or first row again cancel. Dou over dou x of 0. Minus dou over dou z of x square plus y square. Plus k. And third column first row cancel. And dou over dou x of minus 2xy. And minus dou over dou y of x square plus y square. With the help of this formula, we calculate this. So curl F vector is equal to, now here, this 0, 0. This is the 2xy and here is z. So this is constant with respect to z. Value of this 0. And this also 0. Here is no z. So this is also 0. Both functions are 0. So k here. Minus 2xy differentiating with respect to x. So we get minus 2y. And x square plus y square differentiating with respect to y. So we get 2y. Finally here k vector minus 2y and minus 2y. So minus 4y here. Minus 4y and k cap. This is equation 14. We know that surface S is, in surface S, n unit normal vector is equal to k vector. This is xy plane. This is only plane is xy. Our surface is xy surface and our unit normal vector is perpendicular to xy surface. So this is n vector. This is the direction about z axis and z axis along is k vector. So n vector, unit normal vector and parallel to k vector. So both are same vector. N unit normal vector and k vector both are same. We can put n vector equal to n unit normal vector equal to k vector. So now we find here curl F and dot product with n. So curl F, value of curl F is this, k minus 2y, 2y and n unit normal vector here. So minus 4y k unit vector and n is also k unit vector. So k dot k is 1, that is minus 4y. So now we have here formula. This is the LHS. This is the RHS formula of Stoke theorem. Double integration surface S curl F vector dot n ds. So we have find here value of this integral. Double integration has minus 4y dx dy. This result is minus 4y. We have already calculated this curl F dot n. So integrating this result, minus 4 taking common. So here by. Basically we check out the by. By is goes from 0 to b and x goes to from minus a to a. We have already applied the limits. If we want to integrate of y, Then apply the limit 0 to b and integrate of x. Then apply limit minus a to b. So here minus 4 by dy is constant. We integrate with respect to x here first. So minus 4 by dy integration dx, 1 dx here. So integration is x. Apply limit minus a to a. So we get here minus 4 by dy here dx. Minus 4, 0 to b by dy x. Minus a to a. This equal to minus 4 by dy. A minus minus a. So this is 2a. Minus 4 by dy a plus a. This is 2a. 2 4 is 8 minus 8a by dy. Integration of by dy is by square by 2. And 0 to b. So apply limit here minus 8a by square by 2. Minus 8a and b square by 2. So 2 4 is 8 here. Minus 4ab square. This is the right hand side. This is equation 14. We see that here the value of the right hand side of Stoke theorem, that is, here formula is this, double integration s curl f dot n cap ds. So we calculate the value of this side. This is right hand side. So we get here minus 4ab square. And we have already find value of I1 plus I2, that is minus 4ab square. So value of LHS and RHS both are same. So RHS equal to here we see that formula RHS double integration s curl f dot n ds equal to minus 4ab square. This is right hand side. And same value is left hand side. Left hand side equal to right hand side. Verify the Stoke theorem. Now problem 2 based on Stoke theorem. This is other problem. So we want to discuss here. In this problem, we not verify the Stoke theorem. We find the value of line integral with the help of surface integral. So we apply here Stoke theorem in this question. So in this question, evaluate. Evaluate means find. Find the value of this integral c f dot dr. Why Stoke theorem integral c f vector dot dr. This is line integral. And this integral has curl f dot n and ds. We find out the value of this integral. Then this is automatically equal to this with the help of Stoke theorem. Here f vector point function is given this y square I cap plus x square j cap minus x plus z k cap. And C is the boundary of the triangle with vertices 0, 0, 0. This is vertices of origin. This is origin. And 1, 0, 0. This is point, another point. And 1, 1, 0. Three coordinates are given in our question. It means with the help of three coordinates, we get a triangle shape. After meeting these three coordinates to each other, then we get triangle shape. Now solution start. Solution. Here we see that in all coordinates, coordinates 1, that is origin, coordinates 2 and coordinates 3. In all coordinates, the value of z always be 0. Here z always be 0. In all coordinates, there will be value of z. There is not given value of z here. It means this is not 3 dimension. This is only 2 dimension body. If in any coordinates the value of z is given, it means this is 3-dimensional body. So in all coordinates, the value of z always be 0 here given. So this is the 2-dimensional body, 2-dimensional shape here. Each vertex of the triangle is 0. Therefore, the triangle lie in xy plane. Our triangle lie in xy plane. If xy plane, then n cap always be equal to k cap. This is remember point. If surface is lie on the, if surface is lie on the xy plane, then n cap always equal to k cap. So now here, curl f. First we find out the curl f. Here, draw the coordinate. This is x-axis. This is x-axis here. This is y-axis. And this is origin. This is O origin. O 0, 0. And this is y equal to x is a line. This is line AB. So first coordinate 0, 0. Second coordinate 1, 0. And third coordinate 1, 1. This is wrong here. Not AB. V is 1, 1. So first of all, our integral double integral S curl F vector dot dn dot n vector and ds. So this is formula. In this formula, we see that first is curl F vector. So curl F vector I am finding here. I, j, k in first row. Dou over dou x, dou over dou y and dou over dou z. In given vector point function f. What is f here? F is given here y square I cap and plus x square j cap and minus x plus z k cap. So this is vector point function given in our question. So now coefficient of I is y square I am putting here. Coefficient of j is x square putting here. Coefficient of k is x plus z putting here. So after opening this, we get this. Here first I taking here. First row and first column cancel. Dou over dou y of x plus z minus. And minus dou over dou z of x square. This. Minus j second. First row and second column cancel. Dou over dou x of x plus z. Minus dou over dou z of y square. And dou k cap, dou over dou, this first row and third column is cancel. Then here cross multiply dou over dou x of x square and dou over dou y of y square. This is curl f, equation 1. So now curl f equal to here first result 0. Why first result 0 here? Here differentiating with respect to y x plus z. X plus z is constant with respect to y. So the differentiation is 0. Here differentiation with respect to z of x square. X square is constant with respect to z. So differential of this also 0. Here also differential with respect to x plus z. So minus 1 is here. And this result is 0. Here x square 2x. And y is 2y. So finally we get here this 0 and this 0. So here k. 2x and 2y. Here is 2x and 2y. I cap. This result 0, 0. Minus j cap. And here what result is? J. This 1 and this 0. So j here 1 and plus k cap. Here is 2x and minus 2y. Here is minus 1. Here is minus 1. So here is plus j and 2 is common. 2k x minus y. So now curl f dot n. Curl f is this, j plus 2k x minus y dot n. Dot n unit vector equal to k cap. So writing here j plus 2k x minus y into k cap. Now multiply here jk is 0 and k dot k. So we get here 2x minus y. J dot k is 0. After multiply here j dot k. J cap dot k cap and plus 2k cap and dot k cap and x minus y. So this result is 0 plus 2. This is 1 and x minus y. So final is 2 into x minus y here. J dot k is 0. J dot k, j and dot k cap. These are two vectors which are mutually perpendicular and both are normal vector. And the angle between j and k is 90 degree. So the dot product is 0 here. Equation of line OB is y is equal to x. By Stoke theorem we have integral, this is Stoke theorem formula. This is formula for Stoke theorem. Integral C f vector dot dr vector equal to integration double integration s curl f dot n ds. Curl f dot n cap and ds. This is complete formula. This is equation 1. Now, curl f we have already 2 into x minus y. This is curl f dot n. So here 2 into x minus y and into ds. This integral c, here integral c f vector and dot dr vector. This equal to double integration s, here curl f vector and dot dr vector. This is n cap and into ds. So value of this we have find is this value into ds. Now ds is dx into dy and double integration. Here x goes in our diagram, please check that x goes from 0 to 1 and y goes from 0 to 1. Zero to 1. Here is also 1. So now, yes, 0 to 1. So integrating this here y, x minus y. So this is wrong. Now integrating this 0 to 1 and 0 to 1. 2 into x minus y dx and dy. Okay. First of all, integrate with respect to y here. X taking constant. So 0 to 1, 2 into dx and integrating 0 to 1. Here x minus y and dy. So integrating this. Twice of 0 to 1 and dx integrating this. X y minus y square y 2. Limit 0 to 1. So twice of 0 to 1 and dx. Now putting in place of y is 1. So we get x minus 1 by 2 and dx. dx is this. Y minus 1 by 2. So this equal to here 0 to 1 and 0 to x. We solve here integration c or vector f dot dr vector. This equal to double integration s. Here is 2 x minus y dx and dy. So there is some mistake in PPT. So I am solving here clearly. Now integration 0 to 1 is x and integration y is 0 to x and here twice of x minus y dx dy. So first of all 2 is constant taking out. First we integrate off with respect to y. So dx taking it out. Now 0 to x integrating x minus y and dy. So we get here 0 to 1 and dx. Now integrating this x y minus y square by 2. Limit 0 to x here. Apply. So this equal to twice of 0 to 1 dx. Putting limit here x. So x into x minus x square by 2. And lower limit is 0. So finally here this equal to integration c f vector dot dr. This equal to, so here twice 0 to 1 and now x square minus x square by 2 and dx. So this equal to twice of 0 to 1. Here is x square by 2 finally. X square minus x square by 2. Taking LCM 2. 2x square minus x square. So this is x square by 2. So this dx. So 2 is cancel here. Integration is x cube by 3. So now putting limit this, we get here 1 by 3. Okay. So now integration of c f dot dr vector, this equal to double integration as curl f vector dot n vector and ds. This equal to 1 by 3. This is the value calculated by line integral, which is given in our question. Vector point function is given, but dr is understood. Value of dr, r vector is xi plus yj plus zk. This is our position vector. We calculate like this position vector. This is origin. This is x-axis. This is z-axis. This is y-axis. Now this j cap. This is x cap. And this is k cap. So this is x distance. This is a point. X comma 0 0. This is b axis. Y axis. This is j cap. This is y. So this is b. This is c. A p point. So this is z. This is j. K cap. So now OP. OP equal to vector. This equal to vector OA plus vector AB and plus vector BP. Okay. So this is x-axis and along x-axis plus y-axis along J plus z-axis along K. This is R vector OP. Now differentiation with respect to our dr vector. Dr vector, this equal to dxi plus dyj and plus dz k cap. This is dr vector. This is r vector. Okay. So this is the value we have find with the help of Stoke theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.